This lesson is all about reflections. So we're going to take a line, and this line, imagine it being a mirror, is known as the line of reflection. You're going to take a pre-image and reflect it in the mirror, and this reflection, its image, is basically the same thing reversed. It's flipped. A reflection is an isometry. It's not going to change the shape or size of the object. So we're not thinking funhouse mirrors. This is just a normal mirror that you're standing in front of the bathroom sink brushing your teeth in, where it just gives you the reverse image of you. This red line that you see is going to be line M, and any point that is not on M must be on the perpendicular bisector. What this means is I have this object A, and its image is on the perpendicular bisector, so it's 90 degrees to the mirror. Then if you have B, which is just another object that is directly on a mirror, so imagine you put your nose right up to the mirror, well then its image, B prime, is at that same point. It's on the line M. It's on the mirror. Hence, any object reflected by a mirror is perpendicular to the mirror or on the mirror directly. Recall that a horizontal line is an equation of the form y equals whatever, y equals the function. So a horizontal line looking like this is a y equals line, whereas a vertical line is an x equals line because it cuts through the x-axis. And you're going to need to know that in terms of reflecting when I ask you to reflect on the vertical or horizontal axis. In this example, we're given a polygon, the polygon RST, and they want us to reflect it across the line y equals -3. So it's important that you know how to graph y equals -3. If y is -3 everywhere, it doesn't matter what x is equal to. So y is equal to -3 here, it's equal to -3 here, here. It's equal to -3 all over here. So again, in the last slide I taught you that, or reminded you that, a y equals equation was a horizontal equation. Now I want to reflect this across this line. So what I can do is take each point and flip it to the other side symmetrically. So R is going to become R prime right here, R prime. S is 1, 2, 3, 4 units away from the line, and remember this has to be perpendicular. So I have to do 1, 2, 3, 4 units to the line of reflection, and then 4 units this way. And I can graph my point, or plot my point here, and label that S. And then finally, T lies directly on the mirror, or the line of reflection in this case, so T and T prime are at the same position. I can now connect my figure. And as you can see here, it is a mirror image of what we started with. So we have the pre-image and image are just reflections across from this line, y equals -3. One thing I want you to notice is that for each of these points, take S for example, the x-coordinate did not change. We had x was equal to 4, y was equal to +1, and now in the reflection, the x-coordinate is still 4, but the y-coordinate is 1, 2, 3, 4, 5, 6, 7 in the negative direction, so it's -7. What this tells us is that a reflection across a horizontal line does not change our x components, but it does change the y values. So let's generalize this. The coordinate rules for reflections. If AB is reflected on the x-axis, its image is the point, again, A does not change because it's reflected horizontally. The x-axis is horizontal. So A is not going to change. If you start with A, comma, B, you're going to end with A, comma, but B is going to flip over the x-axis, so this will be -B. Similarly, if now we're reflecting about the y-axis, A is going to change. The x value will change, but the y value will not change. So this becomes -A, comma, B. These last two I'm just going to list here for now, and we'll go over them a bit more extensively in class. If AB is reflected across the line y equals x, the image is just the reverse, B, comma, A. You switch the x and y values. And then lastly, if you're reflecting across y equals -x, it's just -B, comma, -A. A few examples is sure to clear up this concept. So we'll start with this example, which has polygon or triangle ABC, and we're going to reflect it across the x-axis. So the reflection across the x-axis, as described on the previous slide, is it takes any value AB and it maps it onto the value A, negative B. So you still have the same x value, but now the opposite sign for the y value, or the b value. So for example, it's going to take point A, and it's going to reflect it perpendicularly to point A prime. Now the x value has not changed, just as this describes to us, and the y value started at positive 2, and now it's at negative 2, so it just changes sign. And that's exactly what was expected here. We started at 2, 2, now we're at 2, negative 2. So you can see it graphically and by this translation provided. So I can do this for all of the other points. X does not change for point B, going to B prime, but the y changes sign. It becomes negative 5. So again, I can reflect that across the x-axis right here, positive 4, minus 5, and call that B prime. And then lastly, C, x does not change, we stay at 6, and the y value becomes negative 3. So 6, negative 3, plotting that on our graph right here, and we can connect that triangle, which is now the image of our pre-image, ABC. So the image again is A prime, B prime, C prime. Make sure that you're always labeling. Using similar methods and the translation described for reflection about the y-axis, I want you to try the next example on your own in your notes. In this last example, we're going to take the triangle ABC and we're going to reflect it across the line y equals x. Remember, y equals x is a line that has the y-intercept of 0 and a slope of positive 1. So it looks like this. To reflect across this line, we had the property that I gave you earlier. And this was it takes any coordinate, AB, and it maps it onto just the reverse, B, A. So you're just going to take the x value and flip it around. Now, we don't have any coordinates given on this plane. So A represented here is negative 1, negative 3, which means A prime must just be flipping around, negative 3, negative 1. I can go and graph that as well. Negative 3, negative 1, and we have it there. What you should notice is that this is perpendicularly reflected across that line that we drew, and it is in this case. Now keep in mind, make sure to label that as A prime. The coordinate B is positive 2 and down 4, so negative 4. So B prime is going to be negative 4, positive 2. It's just reversing the x and y values. So negative 4, positive 2 puts us right there, and we can call that B prime. Again, it is perpendicular to the line drawn between B and B prime. It's perpendicular to y equals x. And then finally, point C is 3, 0. So C prime must be 0, 3, just reversing them around. 0, count up 3, that's C prime, and connect A prime, B prime, and C prime, and you'll notice that it does indeed represent the reflection across the line y equals x. I want you to try the last example in your notes to reflect across the line y equals negative x, and make sure you refer back to your notes previously from a couple slides ago that explains the translation necessary to use. It's also in your book if you need help, and we'll discuss this when you come to class the next time I see you.